So hello everyone, welcome back to this class. In today's class we will study the aircraft model and dynamics. So far we have covered the general foundation, how to design the control system. From today lecture we will move towards aircraft dynamics and how to design the control system for a aircraft. Model and dynamics. So I will try to complete this part by taking 2 lectures. So we will cover the following topic. First, aircraft model and dynamics, which is an introductory part. Today we will cover the some introductory part, and next lecture we will try to derive the equational motion of a aircraft. We will try to explain more in the 6 degree of freedom in the next class. So today class we will discuss about the 6 degree of freedom introduction part. So 6 degree of freedom means aircraft can translate in a 3 direction and can rotate in a 3 direction. I will tell you in this class only. Forces and moments of aircraft, again introductory part, and we will write the equation of motion in a compact form, okay, and we will take the aerodynamic model and we will try to understand what is actually mean by aerodynamic model by considering the pitching moment equation, and we will take the aircraft pitch dynamics and we will understand the linear and nonlinear controller, and we will try to derive the aircraft pitch to elevator transfer function because plant is needed in order to design the control system, right? Okay, finally we will try to draw the block diagram. So you can see here the aircraft, it has a fuselage, wing, horizontal tail, vertical tail. So all the things I have explained in the aircraft design course. You may go and see the lectures. So as I said, aircraft can translate in a 3 direction and can rotate in a 3 direction. So what are those direction actually? So this is a x-axis we will consider, fuselage, okay, and if this is a aircraft and this is a x-axis, then on a right side perpendicular to this, for example like this is a x-axis perpendicular to this y-axis and downward is a z-axis. So what will be the y-axis? Y-axis will be somewhere here, this will be the y-axis, right, and down will be z. So it can translate in x direction, y direction and z direction. So 3 force, right? So 3 force clear, right? So 3 force you can write fx, fy and fz. These are the 3 forces you can write. Similarly, one can rotate the aircraft in a 3 direction. One is about this axis, about this axis and about this axis. About x axis, y axis and z axis. Okay. So you can write mx, my and mz, and you may also call this as a rolling moment, pitching moment and yawing moment. So 3 moment. So 3 force, 3 moment, that means 6 degree of freedom, right? How you write f? You write f equal to ma, right? And how you write moment? M equal to I omega, right? Now if the aircraft has a velocity in this direction u, along x it is u, along y it is v and along z it is w. So you have a 3 acceleration, u dot, v dot, w dot. Force is equal to what? mass into acceleration, right? So 3 equation is this. And similarly, if you have a roll pitch and yaw rate, which is PQR, so you can write derivative of that P dot Q dot R dot. Again 3 equation, 336. And if you define the angle, this pitch angle, roll angle and yaw angle, so you can write derivative of that phi dot, theta dot, psi dot, phi theta psi as a Euler angle. Okay. So what is the pitch angle? What aircraft quad make with fuselage x-axis, right? That is pitch angle, right? Similarly, this is a roll angle. Okay. And what aircraft makes with the north? So if say, let's say if the aircraft is flying like this, I will consider this along the west side. I will consider as a north, right? This is west, east, south, north. Correct, right? Correct, right? So let's say if you are flying in the west, then my heading angle is 0. Heading angle is yeah. And if you are flying with along northwest, you will consider this is angle as a psi. So if you are flying, okay, flying with u along the x direction, and what you are making with the north, it is called psi. And what you are making with the x is pitch. And what you are making with the initially your wing was level, right? When you tilt, what your angle you have make with the level, that is roll angle phi. So since we are talking about the dynamics, you will take the derivative phi dot theta dot psi dot. This u dot v dot w dot is in which axis? Body axis, right? So if you transform from body axis to inertia axis, you will get something, right? So let's say x, y, z are the position. Position we always measure with respect to the inertial frame, and derivative of this is x dot, y dot, z dot. So how many equations are here? U dot, v dot, w dot, p dot, q dot, r dot, phi dot, theta dot, psi dot, x dot, y dot, z dot. So total is 12. So this part is clear, right? 6 degrees of freedom, force and moments of aircraft, and I will write the complex form of the dynamics now. So u dot, v dot, w dot, p dot, q dot, r dot, phi dot, theta dot, psi dot, x dot, y dot, z dot. So these are called 12 states: u, v, w, p, q, r, phi, theta, psi, x, y, z. So these are the 12 states belong to the real number which has 12 cross 1 size. And how many contours you are having? See, in a PPT, when you go back here, you will see this is a aileron. Okay, this one is a aileron, and these two aileron, these two elevator, this is rudder, and this is the engine. Associated with the controls is throttle inside the cockpit. Okay, so you will have a 4 controls: elevator, aileron, rudder, throttle. That is a real number belongs to 4 plus 1. So this is a state, this is a control. So if you have any doubt how this functions, you can go to the aircraft dynamics, aircraft design course, and you can see. You can write this in a compact form, right? X dot equal to f of x comma u. Simple. This is a compact form. So x dot is how much? 12, right? And please note here, why I have written x dot y dot z dot. How it is different from u dot v dot w dot? Sorry, how it is different from u v w, because x dot is also velocity, y dot is also velocity, z dot is also velocity, and u v w is also velocity. But u v w are in the body frame, but x dot y dot z dot are in the inertial frame. So you have to transform from body to inertial. Okay, because everything you can measure in the inertial frame. Newton law is applicable for in which frame? Inertial frame. The moment you will measure in the body frame, it will change, right? So that is why you define the three angles, phi, theta, psi, in order to transform from body to inertial, inertial to body, right? So next class we will derive the same. Now we will consider the pitching moment equation, and we will try to explain you, because I think it is better to take the simple example and try to demonstrate the same what you want to convey. Okay, so we will take the simple equation pitching moment my. What is the pitching moment? Half rho v square s c bar into cm. Simple, right? Now you span this cm naught, cm alpha into alpha, cm delta into delta e, right? What is moment? I omega, right? So this is, if you consider the moment of inertia about the y-axis is Iy, then what will be this? What is this rate? Pitch rate, right? So I can write I omega dot, right? So q dot. Q is the pitch rate. Simple, right? And same thing you can write here, half rho v square s c bar cm naught, cm alpha into alpha, cm delta into delta, right? So I am trying to write this equation in this form. Simple. So what you will take? You divide by Iy, right? Here you will write only x dot, right? Q dot, right? So what you will do? You will write q dot equal to, what I will do? Half rho v square s into c bar divided by Iy. I can consider as a simple constant a. So a into cm naught, cm alpha into alpha, cm delta into delta e. Again I will write here. So this is a similar form, right? X dot equal to x function of x comma u, right? Where x is a q and u is a delta e control. Can you relate this to, as I said before? No. If you multiply by a into this part, see, if you multiply by a into this part, you can write as a f. And if you multiply by a into this part, you can write a g. And this you can write u, and this you can write x dot. This is equivalency I want to stabilize. Okay. So in this form you can write. So any dynamics can be represented by this x dot equal to f plus gu, where gu is a control matrix and f is a system matrix. Have you remember x dot equal to ax plus bu, steady space form. Okay. So if you linearize this, you will get the same, x dot equal to x plus bu. No doubt, right? Now, if I write x equal to, let's say k into e, let's say I want to control my, I want to stabilize my rate. I want my rate to be 0. So if you put x dot equal to k, what you can write? U equal to minus G inverse F plus KE. And what is E? E you can write Q minus Q command. And Q command is what? Or you can write Q command minus Q. So your Q command is 0. I want to stabilize my pitch rate. My pitch rate was something I want to stabilize. That means I want to attain 0 pitch rate. I want to fly like this. No pitch rate, right? So I will command 0. And Q is the actual which I am taking feedback. And this is the error. If I will multiply by the gain, it will become the H dot. And finally, if you put, you will get U equal to minus G inverse F plus KE. So now what you are doing? It is G inverse, right? So you are inverting the dynamics, right? So that is why this approach is called non-linear dynamic inversion. Why it is non-linear? Because have you seen this F? What is A? A is half rho V square SC bar IYY, right? And A into this part CM naught plus CM n point 2 alpha is F, is a V square, non-linear, right? That is why I am trying to say it is non-linear. Now, if you flying with a constant velocity, assume that if you change the pitch, there is no change in the velocity, so you can consider F is a constant and G is also constant. So if F and G is constant, then things will become what? Linear controller. So here you can use the Taylor series and you can actually written this form as a x dot equal to ax plus bu. So x dot equal to ax plus bu and x dot equal to f plus gu. This is a linear and this is a non-linear. So from this I am clearly try to stabilize that what is the difference between linear and non-linear controller. But see, approach is same. Here you are also writing error equal to k into q command minus q. And now we will try to aircraft pitch to elevator transfer function, because you have seen in my MATLAB Simulink course also, system dynamics and control, we used to take a transfer function and we will try to implement the PID controller, also in the theory part of flight control system design course. Okay, so we will try to derive the same transfer function. In non-linear controller, are you required for any gain changing and all? No, right? If you put one gain, single gain, na, for all trim point, automatically it will be, gain will be automatically computed, because what? G is a function of the what? Y square, right? So see, for example, what is F? A into Cm naught plus Cm alpha into alpha, right? And G is what? A into Cm delta, right? A is having what? Half rho V square SC bar by IYY. So when you change from the one flight to the another flight, velocity will change, so G value will be changed. So you are basically adopting the situation. That is why every time gain selection is not required here. You are automatically computing this. You can see this is a G inverse sitting here is you can say it's a gain. It's taking part of the gain. Okay, F is taking part of the gain. So there is no need for a gain scheduling. In this course, you will require a many gain when you switch from one trim point to another trim point, because when you design the linear controller. But when the non-linear part is concerned, this will be automatically computed. For example, see this, x dot equal to x plus bu. A is what? System matrix, calculated to the one particular velocity trim point, right? B also one trim point, right? When you change the trim point, this AB will change. So every time you have to compute the gain, but here it is taking care of GNF. That's actually I'm trying to explain you. Now, we will write this again, Cm naught, Cm alpha into alpha, Cm delta into delta E. Okay. See, if my roll pitch and Ya is very small, then I can consider this pitch rate is nothing but the theta rate. What angle I am changing the what rate I am changing the angle, that is nothing but the pitch rate. So I can write theta dot equal to q, right? So theta double dot will be q dot, right? So I can replace this as a theta double dot equal to a cm naught, and I am flying at steady state level flight, right? Where flight path angle is 0. So you can write theta equal to alpha, right? So you can write cm alpha equal to cm alpha into theta. Now here please note down cm naught, cm alpha, cm delta E. This all is the, you can find out how to estimate this in my aircraft design course. This cm alpha is pitch stability derivative, cm delta is a control derivative, okay, and cm naught is a pitching moment coefficient at a zero angle of attack. So cm naught, cm alpha, cm delta E, this is a representation of a aerodynamic model. Depending upon this value, your aerodynamic model will change, okay. So this plays a very significant important role. What are the sign, how to estimate this? You can go to the aircraft design lecture and you can see actually how to find out this. So if you see what is what are the aerodynamic model, then you will see cm naught, cm alpha, cm delta is my represent my aerodynamic model, okay. So this is control derivative cm delta E, and this is stability derivative cm alpha, okay. And you will write one more term here, CMQ QC divided by 2V. Okay. So here also you can add this term plus CMQ QC divided by 2V. You add this term CMQ QC divided by 2V. You add this two term CMQ QC divided by 2V. Add this two term. So CMQ is a damping derivative. This is pitch stability derivative. This is a damping derivative. So this decide how much natural damping you are having. Okay. You have studied, right? Omega n and zeta, right? So CMQ value is high, zeta value will be high. You can relate this. Now, and why I have written QC divided by 2y? Because you have to non-dimensionalize the things. This pitch rate has some unit, radian per second, right? So you have to non-dimensionalize. This is why QC divided by 2 we have written. Now, this Q dot further you can write as a, what you can write? Theta dot, right? This equation, okay. In order to find out the model, what you will do? Take the Laplace transform, right? So what is the Laplace transform? S square theta A Cm naught Cm alpha theta plus CMQ C by 2V theta of S plus Cm delta E of S. Simple Laplace transformation I have taken. So here what is the input? Transfer function is, you have to write in terms of output by input, right? So here is the output is what? What is the output? Pitch angle, right? And what is input? Elevator, right? You are giving the elevator in order to see the how the aircraft pitch is responding, right? So you can write, so you can rearrange everything and you can write in terms of theta s and delta es. And also, in order to simplify, you consider this as a 0, or you can consider as a in disturbance part, right? In disturbance part you may consider. Okay, so you can write output by input. What you can write output by input s square a1s plus a2, and this is you can write b. So please tell me what is a, what is b actually? Second order, right? Perfect. That I am trying to say this. So what is b? B is what? A into cm delta e. And what is a1? Please tell me with sign. Minus a cm alpha. Perfect. What is a2? Please tell me. And here you will write, this is a derivative, right? You will write s theta s. Okay. So what is a2? Please tell me. Minus a cmq c by. Now everything is clear, right? So how you have arrived the second order transfer function? That is why I have in the previous lectures I have tried to explain you the what do we mean by the second order system. Now in the real actual case we are arriving to the second order system. You will give the elevator and you see the pitch you can control. Now you have a transfer function, you have a model in your hand, you can control whatever you want. Now if I want to draw the block diagram, so what I will do? I will take this transfer function, right? What is the transfer function? B s square a1s plus a2. Simple. This is a transfer function, right? So I will write s here and I will write 1 by s here. So s and 1 by s will get cancelled, right? So here I can write actually q, and here I can write I can write theta. No doubt, right? Now here I can write plus minus, and here I can give the q command, and here I can take the feedback and I have multiplied by some gain, let's say kq. I will close this loop. So now what I will do, you close this loop, and this is q command. And now what you will do here, you will give the theta command and you will take the theta feedback here, and here you will use the what controller? Pi, and this is d, because theta dot equal to q. So this is the d part, this is the pi part, and you can give the theta equal to some degree, 1 degree, 2 degree, 3 degree, 4 degree, okay, and you can control. So to start with the most inner loop, you have to get the q first qc equal to 0 in order to stabilize the rate loop. This is called rate loop, okay. And by changing the q, you can change the q by using root locus. Now you have a second order transfer function, right? Once the stabilization is done, you may integrate this in order to get theta, and again the closed loop, and by changing the pi you can actually get the desired response what you want. Okay, thank you very much. We'll meet in the next class.